Here we go. Here we go. Here we go. Today we are doing 8.7. And this is factoring special cases. So we are factoring just like we have been, especially yesterday, right? We're just going to do special cases today. Now, when we multiplied things together, we said there were two special cases. One of those was a perfect square. And the other one was called the difference of squares. Do you recall us talking about those two things? Kind of. That's good. It's really good. All right. So we're going to start with a perfect square. A perfect square is a trinomial that when you factor it has two identical factors. Right? That makes sense? So that's what we're going to start with. We're going to start with example number 1. And this is going to, I got to get on the right page. This is going to cover 10 through 22. Yeah, but some of them are super quick. Super quick. All right, so factor. We're going to start by factoring something as wonderful as x squared plus 18x plus 81. So first we take out the greatest common factor. Is there one? No. Then we draw our x. Last number times the first is 81. Middle number is 18. What are the sides of my x? 9 and 9. That's what should happen on every problem today. For the first half anyway, right? Is that our sides are exactly the same. Now, in this one, do we need to do the box? No. Why? Yeah, it's got a 1 on the front. So we have x plus 9 times x plus 9. Or you can write it as x plus 9 squared. Which is fine with me. Example number 2. Still from the same section. Let's just make it a little harder. Let's say we have factor 4x squared plus 36x plus 81. Fix that writing there a little bit. All right. So first thing, there is not a greatest common factor I can take out of all of it, right? So I'm going to draw my x. Last number times the first. 324. Middle number is 36. So when you start getting big numbers like this, the first thing you should always check is take that bottom number, which is 36, and divide it by 2. 18 and 18. Check to see if 18 times 18 gives you the top number. Okay? So now we're going to go to our box. First spot is 4x squared. Last spot is 81. Our diagonal is 18x and 18x. So out of the top line, what do I have in common in both 4x squared and 18x? 2x, I agree. I can't take 4 out of 18, right? I mean, you can think of it this way. This is 2 times 2 times x times x. And this is 2 times 9 times x. So we have a 2 in common, and we have an x in common. All right, how about the next one? What's in common at 18x and 81? 9. Good, positive 9. Up and down, I already used 1, 2, and an x. So what's in common this way? 2x. And what's in common in 18x and 81? Awesome. Correct. 2x plus 9 squared. Exactly. All right. Let's do one more underneath that one real quick, and then we'll go to the other one. Okay? So let's do one that's really big and ugly. How about 49x squared minus 84x plus 36? So we're going to draw our x. Last number times the first. What is 36? Okay? And middle number is negative 84. What did I just tell you the trick was when the numbers start getting too big? Good. So we get negative 42 and negative 42. Double check and make sure that multiplies to 1764. All right, so we're going to do our box. First spot is 49x squared. Last spot is 36. My diagonal is negative 42x and negative 42x. Out of the top line, I can take a 7 and an x. On the bottom, there's a negative, and what else is in common? Good. Up and down, 49x squared and negative 42x is 7x. And again, negative 42x and 36 is negative 6. Good. Perfect. See, these aren't so bad, right? Okay. So then let's move to difference of squares. Okay. Here is example number 3. It's actually 24 through 38. Yep. All right, I want you to factor 81x squared minus 1. All right, is there a greatest common factor that can come out of it? Okay, so I'm going to draw my x. Last number times the first is negative 81. What's my middle number? 0. There isn't a middle number, is there? So it's 0. We have a first number and we have a last number. We don't have a middle one. No, good try. That doesn't multiply to negative 81. No. How about negative 9 and 9? All right, so let's go to our box. You guys are so funny. First spot, we have 81x squared. In the last spot, I have a negative 1. In my diagonal, I have negative 9x, and I have a positive 9x. Because they would have canceled out, right? Now we got to undistribute, though, to find our factors. What can I take out of the top line? 9x. How about out of the bottom line? Good. Up and down, I can take out a 9x. And here I have a negative 1. So I have 9x plus 1 and 9x minus 1. This is called the difference of squares because this is a perfect square. It's 9x times 9x. And this one is a perfect square, which is 1 times 1. And we have opposite signs. Okay? Last example right here. Now I'm done. Example 4. Factor. Let's go with 80x squared minus 45. What is always the first thing we look to do? Take out a what? And what would be the greatest common factor here? 5. Very good. 5. Take out a 5. 5 goes into 80 16 times. And 5 goes into 45 9 times. All right, so now we're going to go ahead and draw our x. Negative 9 times 16 is negative 144. What is my middle number again? 0. Now I need to find the sides of my x. Very good, Haley. 12 and negative 12. Good job. And we go to our box. First spot is 16x squared. Last spot is negative 9. That diagonal is the 12x and negative 12x. Out of the top line, what's in common in 16x squared and 12x? 4x. I heard that. Thank you. How about on a negative 12x and negative 9? And remember, there's a negative right here, so negative 3. I completely agree. Up and down, 4x and 3. And again, if it's the difference of squares, they should be the same with opposite signs in the middle, right? 4x minus 3 and 4x plus 3. Awesome. That's today's lesson. Yes. We're doing 10 through 38 even.